because the world runs on business and business runs on software. How do you optimize communication within human organizations? That's really the fundamental problem. We humans come together, we make companies, and we impact the planet, and the way we organize companies in modern days, it's the nervous system of companies is software.
Beyond ChatGPT and AI agents lies the next true frontier, AI as a software platform. You're going to hear that buzzword from now on a lot. I'm Masoud Alabash, CEO and co-founder of Omadeus with 3 prior exits. In my previous company, to manage projects and collaboration for over 200 people. Like most tech companies, we cobbled up tools such as Jira, Slack, email, Trello, just to name a few. Euphemistically, we called it controlled chaos. It was a mess and it really never worked. And that's because with software today, the code is in charge and data is just a passive slave that gets shuffled back and forth. After the sale of our company, we came together and raised about $3 million to create a new technology that flips this current model on its head and puts data in charge. Omadeus makes data self-aware by giving it a TLM, tiny language model, and its own memory so it understands the workflow and its relationship with people. This clever approach handles security, privacy, and solves the hallucination problem. Imagine if every part of your business has its own AI brain, turning data into autonomous intelligent agents. These agents manage all the information about themselves, including documents, spreadsheets, conversations, even handle your Zoom or Google calls, and remember them all so you don't have to. In short, Omadeus transforms software from a collection of rigid algorithms and passive data into a network of intelligent agents with awareness and control of their environment, while completely subservient to people, the neurons of organizations. Our project management co-pilot has won the Innovation Award from the Computer Science and Computer Engineering Conference. We have 7 patents pending and recently completed a private beta. Today, here, I'm happy to announce that we are launching a public pilot by offering a free trial to everyone here at Disrupt. Come to our booth and experience the future with the world's first AI-native software. And soon, there will be many more, from manufacturing to healthcare, and maybe even your mobile apps.
I'm having fun after having lived through .com days. I'm having fun seeing the unbelievable, deafening hype that is going on, especially about AGI. And I tell you, and I wasn't going to give you a hard time since this is recorded. I think I gave you a hard time for buying that gadget, the Rabbit AI thing, right? Did I give you a hard time for that, Daniel?
Yeah,
yeah, I did. Good. Thank you.
Who knows if it'll work out? You know, let's see how the founder.
Well, I tell you what. I mean, what I would commend them on is the fact that they knew how to do a hype and just get out there. I don't know if there are 2 possibilities. Either they are so naive that they don't understand what they're doing, what they're talking about. Okay, or they know what they're doing and they're riding the wave. And I just think that, to me, that the first whole thing came across as disingenuous because, I mean, come on, we're all engineers. Because this is a good angle to this, and we can use this as commentary on Rabbit AI. Because Daniel knows the day one, I thought it was a hoax. And it's very simple. If you're going to have a chat dialogue and you're going to coordinate actions of different apps, okay, like a human. Number one, that's the problem. So basically, replace the human, have an agent that interacts with your apps. Okay, so that's the premise. Now, I mean, we as engineers, if we're going to solve this, wait a minute. So you're going to train the apps, so navigate the apps graphically. Okay, so I like the whole term, the large action model. It's cute. And to me, that seemed like, okay, if it's some sort of fancy screen scraping, with, this goes back in the 2000s. Like, so I could see how you could train models on navigating, but why do you even do that? Why not just go to APIs? Do you know what I mean? That was my first question. Why do you need to? And by the way, who's going to go in there and train these apps? And how many apps are you going to train on? Like just a handful of 10? And here's the other question. Where are the apps going to run on? Are they going to run on your phone? So you need a connection between you and your phone, because the apps need to run somewhere, right? And either on your PC. So all these questions to me immediately was, excuse me, that's a lot of mumbo jumbo, and this is a hoax. Okay, and because of the smooth demo that he did, it's like that smells, tastes, acts, looks to me like a hoax, and I was shocked. And then I just slapped myself when I woke up and realized, okay, Silicon Valley is the world. You can always the amount, the enthusiasm that they got, and I thought, even a lot of my friends who are like educated, they got backgrounds, they just, because they wanted it to believe it, they overrode their engineering suspicions. You know what I mean? Like, because you want it to be true, right? You want it to be so true. But that as it happens, I'd been working on that same problem since 2017. I mean, in 2017 is when I first did the very first brain dump of, okay, if we solve the natural language problem, understanding natural language, because that was my focus. Was when OpenAI started, we started tracking them, and I started a whole AI department back in the Newsoft days. I started, and I put Sharam on and just said, stop everything. You're the head of AI. Go into the room and don't talk to anyone. Let's hire some people. And we started looking at crunching our data with the claims. But my whole idea was, if we move towards, because it looked like Google had it in terms of translation and language comprehension, they were moving that direction. And to me, I actually was surprised when it was solved that quickly. When we solved the language problem, understanding of natural language, what can you do then? Okay, so for me, the thing to do was figure out how to combine that with algorithms, software. That's where so I've been working on this problem since 2017. That's why I immediately look at it and go, this is a bunch of mumbo jumbo. Because, like I said, why don't you connect to the API to begin with anyhow? Because you and I could easily train an LLM, and people are doing that on APIs, right? The APIs are a lot easier than doing action model crap. And all the issues of orchestrating and coordinating between apps and forget it. This is a really hard problem to solve that way, right? And the paradigm is wrong to begin with. But these guys, in the meanwhile, raised $20 million without selling it in one share, because they pre-sold their place. Like I calculated, I think in the first week they sold about $20 million worth of stuff. The industry is now coming this way because LLMs, the hype of ChatGPT and LLMs just died down, because very quickly we realized they're not all that useful. And I know this is a little bit of a heavy statement. So what happened is, after the hype died down, people realized, well, they can't really solve all those many problems except in terms of business, because the world runs on business and business runs on software. It's simple. As Andreessen mentioned, his famous quote that the software is eating the world. That's how software is eating the world, because we humans come together, we make companies, and we impact the planet. And the way we organize companies in modern days, it's the nervous system of companies is software. If we're the individuals are the brain cells, the cells of the organization, software connects us together. And then you have a variety of custom software, vertical specialized software like accounting systems, electronic medical records. Then you have email, Slack, all these communications. And I wrote a couple of papers. The very first one I published with the IEEE a few years ago, that one is focused on communication, and it's titled workflow-based communication. And then the final end of it is just one paragraph talks about AI. And the second paper, I took that last paragraph and made it into a whole paper, which is what we're working on now. Because communication and artificial intelligence are, in a way, they're two sides of the same coin, solving that problem. But the fundamental problem is communication, and that really runs deep everywhere. It's about how do you optimize communication within human organizations? That's really the fundamental problem. Okay, it's like, how do you optimize it? How do you get information from Daniel to me, or from you to Daniel, the right information from the right person to the right person at the right time? Because there are two components. It's like, who needs this information and exactly when they need it. Now, that needs to be solved. This is the fundamental problem to solve. Vertical software kind of started by doing form automation historically. Like, we had the way we organized before computers, we started organizing in hierarchical fashion, and then we started transmitting information with paper. And so paper from top to bottom was general statements like, everybody work hard, we're going to go to left, we're going to go right. But when you get closer to the assembly line, which is your, and workflow is an abstraction of assembly line. Down there, you need to communicate exact information. You fill out a form saying we need 5 transistors of, or 2 screws of 0.7 inches, and you got to put them in this. So that's how information got exchanged on paper. And essentially, when computers came into existence, we took those papers and stuck them on the screen. That is the model of computing for software solutions that started back in the late 50s or 60s, and then it stayed the same to this day. It is still exactly the same thing. It's like, whatever we do, we've made it a little fancier. We've kind of realized that the screen is a bit more malleable than paper, so we just break those features or fields and stick some here and color it and big buttons, but they're still form-based software. And the model of thinking is form. And more importantly, underneath it, what we've done is the software essentially is algorithm and data. And who's in charge in our model of software? Algorithm is in charge. Data is just dumb information. Give it to me and I stick it in a box somewhere. And when I need it, I take it out, and that box is called a database. And somehow you embed a workflow in there, like an accounting software. I work for you, I do accounts receivable, I go on the accounts receivable screen, I enter some data, and Daniel is my boss. He sees it on the general ledger, and you put in accounts payable. We are communicating that data to Daniel on a general ledger. So these are designed, but these are forms still. I mean, these are forms that you can look up on paper as well. Just see paper forms. It's form automation. That's what we're doing. Even though we went from the 60s to 70s, in the 1980s, we went to the graphical user interface world. That actually made it worse because the GUI was allowed us to kind of create a fidelity with the paper forms. It just looked more like a paper. So that actually made it less intimidating for people who dealt with real world objects. Instead of typing text that's intimidating prior to graphical user interfaces, it made it easier. Basically, if you look at the evolution of software, what it's done is been trying to make it more ubiquitous and available to more people. And graphical user interfaces was one of those first revolutions that transitioned and improved the user interface, but it maintained the form architecture, the form automation architecture. Same. Fast forward, we went to the late 1999, 2000s, and we went into this internet stuff, and we had another transition. Servers locked in the back of an office. If I wanted to get to my accounting system, I had to get in my car, drive to my office, unlock it, and ask my IT guy to boot up the server or whatever, and then sit there and do it. We moved on the internet. Why? The benefit of it is I can wake up Saturday and sit on my underwear and open up and get to my general ledger. Okay, this made software ubiquitous. But and what was the cost of that? When we went through GUI, all the old software had to be thrown away. They had to be thrown away. They were not useful. A lot of old programmers quit. Now, I happen to come from that era because I programmed the old mainframes, and I watched the trend. I was a youngling just like Daniel is today back then. I'm kidding. I know Daniel is a bit of an old timer. He looks younger, much younger than me. But the transition to GUI, even though all the software was thrown away, we came up with a new model of approach of writing programs. No longer as you take an input, do a calculation, do an output. You put an object on the screen, you say that object is a trash can or is a file folder. What you do is this looks like one and it has events around it and you need to customize these events. And when you customize all the events of all those objects on the screen, the interaction of these guys together becomes the program. It's a completely different model, event-driven programming. It's a different architecture because GUI was a platform. It was a platform. And fast forward, you go to the internet, you want to do, before in the old days, me and Daniel would sit in our garage, write some code, put it on a disk or a CD and distribute it to people, just the two of us. And then every time we would just update them like that. And they would all install it on their machines. Fast forward, that model doesn't work anymore. You need front-end people, back-end people, DevOps people to deploy. You have data centers, distributed. It's a distributive computing model. That's where we went to. And what we got out of it, the benefit the user got was that software became ubiquitous. It was available anywhere, wherever you are. You're not tied to the location of a particular machine to access that software. As anywhere in the world, you have access to a network, you can get to your computational. But the software stayed the same, even though the entire model of architecting software changed completely. And we had to throw away all these old programs. We threw them away and we redid them. Again, with this new architecture, because internet is a platform. When you have a new platform, when you have technology as a platform, when you have graphical user interface as a platform, when you have internet as a platform, it has very specific engine ramification. And when you move software to those platforms, you need a new paradigm, new architecture, new way of looking at building software. So event-driven belonged to the GUI. This whole distributive computing belonged to the internet times. And Daniel comes from that era where your previous company also, you guys were engaged in building distributive software of the internet. And everybody knows. You need DevOps, you need backends, front ends, and all those complications that come with it. Now, the discussion has reached now, we've been saying AI is cute as a tool. You can sharpshoot certain problems. You can use these large language models to automate customer service, but they're limited in their use. That's it, because they're word calculators. The industry's figured out to make large language models more useful. They started attaching algorithms to them, to these large language models, and call them agents.
Yeah.
And actually, the definition of agents are really from someone with a bit of academic background and practical as well as an engineer. The definitions that I've seen of agents somewhat lacking. Yeah. The way I define an agent, an AI agent, is combining deterministic algorithms with probabilistic engines. When you do that, you've got an agent. And these large language models are they're very computationally intensive, they're expensive, and they can answer any question about anything. The most use these LLMs like ChatGPT they've had is really making search efficient and doing some basic functions like summarization, outlining things, and which is really, these are useful functions, but they haven't been able to touch software because business runs software and software need re-engineered to run on AI as a platform. Okay, because if AI is a platform, then the software needs to be re-engineered to run on AI as a platform. Now the question is, what does that architecture look like?
Just going back to your initial pointer, about Rabbit, where we were actually talking about the R1 and the large action model. So you might have definitely heard about computer use by Anthropic, which was just released yesterday, 24 hours ago, and I'd really love to get your pointers on this, because I understand that you're talking about software, and now it's AI and LLMs that's using LLMs to build software, and that's actually possible right now, right? It's able to move your cursor, it's able to take the screnershots of your screen, put it back in the LLM. Beautiful. Yeah.
Okay. So this is that's a great angle, and it's an. If the history is repeating itself, and now AI is a platform, because I hear that now. I hear it from other people. And I actually just heard it from, I don't know if that should be, but I heard that on a presentation because we're part of the teams at Disrupt, and some Google people gave a masterclass on and I participated in the gentleman had a great presentation, and he talked about AI as a platform. It's not just a bunch of tools. And I asked the question, well, if it's AI as a platform, then what are its ramifications for software? And so he asked, he basically was kind of thought that question is too vague or too broad. And so I couldn't really have a direct dialogue with him. I'm going to pursue that. What I'm beginning to see is people are beginning to smell this, that AI is a platform, but they have not thought it through as to what are the ramifications of what does a software on AI look like? What do you do? Is it like when we went event driven? Now, is this some other, when we went to internet distributed, what is this going to look like? Okay. Now, the question he came up with about Anthropic, spitting out code from these LLMs, it's not that big of a deal. Okay. First of all, and the reason, it should be easier for them to spit out code than a natural language. And mainly because natural language is vague and computer language is very deterministic. And you can write a very strict grammar about it. That's why when you run your program through a compiler will tell you exactly what's wrong with yours. It's like, and it will always do what you tell it, not what you mean to tell it. So humans confuse, and that's where the nature of bugs. Bugs are what you think you're telling the machine and what the machine is understanding specifically. Now, LLMs should be able to produce code, okay? And for things that can fit into a specific constraint. For example, moving a cursor, you say, all right. Or, I don't know, the specific type of websites, all right? So like if you design one and you design the same over and over again, then have a template. And we can abstract that and say, here's a model to create 10 different websites. And here's the architecture of that model. When you define that in a very specific way, you should be able to go to an LLM and describe, I want this type of website with this in it and that in it. It should spit out the code. There's not really... People should not be enamored with that. We should be able to do that using templates anyhow, which template driven. There are lots of tools that they went in that direction where they're trying to make simpler for an end user. In the early days, you had to know HTML to build websites. Now you just need to know how to navigate a GUI software to build the majority of these websites. So isn't that code generation? The idea of code generation is not all that impressive. What people are enamored about, if I really say, is the fact that you can talk to it, right? So it's the natural language understanding saying, make me a website that has a picture up there and a blinking button on the left side. Instead of you going clicking on a GUI and say, this is a blinking button, drag it over there. Here's a picture that flashes, drag it over here, go, right? You're doing the same thing. What you've done, you've replaced the interaction for the end user by navigating through graphical user interface model to a natural language model. That's all you've done, okay? So, and there's nothing wrong with that. Now, the beauty of this is the following. When we kind of came up with it took us years to come up with this architecture that what is software supposed to look like on AI as a platform, okay? And it turns out you have to first solve the communication problem. You have to have a new model for communication within an organization that can guarantee optimization.
We are talking so much about large language models and the models and behind the whole AI itself. And you must be knowing this term in AI which we use as garbage in, garbage out. And now if you want to build the systems that really are impactful, we need that kind of training data, right? And the AI can just be as good as the training data that humans can give. So how can we even get to that point where the AI is so good that it's just able to solve real world applications? And is it just synthetic data training, or how do you think that's going to happen? And would love to hear from you here.
Okay, I love your question from two angles. The one, and you're not unique, this is prevalent. You are now phrasing a question based on the way you understand the AI landscape with all the dominant narratives. Okay, so that's how you phrase the question about data. What do we do with data? How do we actually don't avoid garbage and garbage out? You are basically envisioning data as some sort of feed to this horse, the AI horse, or whatever AI engine that's going to read it and digest it and then produce some meaningful output from it. And I think the analogy of horse is very apt in this case. That's not what it's about. To solve questions, you're talking about, with that model, you're talking about how do you improve LLMs? How do you move and how do you get to AGI, which is really, I challenge anyone to give me a definition where I as an engineer can understand and can measure once it shows up. I say, oh, okay, this is AGI. I was like, nobody's defined it. So this is all a lot of hoopla, if you ask me, okay? And there's a reason, it's part of the hype. This is a bigger hype than Rabbit AI, okay? I'm not saying good things are gonna come out of that, okay? But majority of it is hype. To really apply AI in a meaningful way to the daily problems that afflict human beings, we don't need probabilistic machines to guess what our problems are. I don't need to train AI on the fact Daniel is the CEO of his company and his relationship with Harshit is that, or James is a programmer who works for his company. I don't need to train any AI. We already know all this. Okay? There's a time, and we've actually coded these things in these software models. In his project management tool, in their payload, they set it up, right? All this information. We don't need to guess at it, okay? What we need is a different kind of architecture for software such that software becomes intelligent. When you turn on your software, you don't need to be trained on it. Not only becomes super intelligent, that when you turn on it, it can speak natural language, and it says, hello, Daniel, these are the things that are waiting for you today, okay? And it knows. Why? Because he logged in and knows, the software knows he's the CEO, and he knows that he's interested in this stuff. And this part of the project is important for him. The software knows that he's a primary doctor, and today he's coming, and these are the 3 top appointments that he had. Information, we all have all of that, okay? We as humans, we already know. We as programmers know that. But we don't have the right tools in the way we craft these programs to allow them to make intelligent decisions. Never before, as a programmer, did I have access to a facility where I can program an object and say, you are an X-ray object, and the engineer is going to take a picture and a film and attach it to you. Now, once he does that, this is all deterministic algorithms, right? I'm writing an algorithm. Look at that. Once he does that, make sure you remember his name. Well, okay, so today's stuff. And by the way, look at the type of the X-ray, because he's going to define the type. You don't even have to read the film. The engineer is going to say this is an X-ray of chest, or mammogram. Okay, so it defines all of your attributes. You're born as an X-ray object. You're born. You have a film. You have a type. You have all these attributes. Now, once you have these attributes, feed these attributes to this algorithm right here. Number 1. And that algorithm I wrote says, all right, if X type is chest, go to this predefined address that we have a contract with in Clinic's network, pass this authentication token so it allows you and builds us properly, feed the film into the engine and wait for a report to come out. Okay, it does that. And now the report came out, read the report, look for these words. Never before have I had access to that. Now I do, okay? Now I can write programs and make, instead of now putting all intelligence into the algorithm, now with this new architecture, if I put the intelligence in the notion of data, if you think about just that example, imagine if I made every data element, the blood tests, the insurance object, the appointments, all these transactions, if I treated the same view that I said, this is who you are, these are the algorithms you have access to, these are the set of attributes you're going to be getting. Once you get all your attributes, you start moving around. in the workflow. And as you run around and do things and things happen to you when your attribute changes, inform all the right stakeholders. So I can create a issue request and say, hey, I need, or a bug report. Say, hey, the function has a bug. So when I create it, that's an object itself. The bug itself knows where to go. It knows, okay, for this project, I'm going to go to Hashith. He is the project manager. I'm going to show up, say, hey, I'm a bug report. And you can go in there and say, wait a minute, the priority of this thing is very low. The minute you do that, you change the attribute of this object. And the object, when I created it, knows its relationship with me. You don't need to do anything. You just interact with it. And then it says, oh, okay, good. It'll translate that action into text, puts it into memory, and it delivers itself to my inbox and says, hey, something happened to me. And I look at it and go, whoa, has she changed the priority to low? Wait a minute. I'm just going to go into the object and say, Daniel, this is very important. I got 10 customers waiting on this. And he's sitting there doing his own business. The object says, oh, okay, I'm going to go deliver myself to Daniel. And it shows up. And Daniel looks at it and go, wait a minute. 10 people have been talking in this. I'm busy. I don't have time. Because that object is intelligent, it says, listen, give me a highlight of what's going on about you. It says, oh, I did this happened, blah, blah, blah. It's like, okay, well, let me see the actual image. Oh, let me see what customers are tied to that. Wow. Oh, these are important customers. He just tells the object, this is very important. It needs to be on high priority. Guess what? All of that, you are also a part of it because you're part of that conversation that the final message will come to you and to me. But the object brings it. It's not a message. The object comes in your box. So that's why the object messaging. In other words, everything is about messages. Now we need a world that can exchange objects. And these objects are intelligent. They're programmed by the programmers. Forget this data feeding and training and synthetic data. That's a different world altogether. That's about how do you improve LLMs? How do you get them to focus on a particular vertical? Because now we're going into SLMs, like small language models. Because if I'm training somebody, some tool in my kitchen, I don't need it to be able to change the oil in my car. Right. So, I mean, I just need it on my kitchen. So that's an SLM, right? We take this one step further and say, no, we need a TLM for these. And it needs to be a tiny language model. All it needs to do is understand language and be able to understand all the ones the things that I talked about, know its attributes. Like your size 15, you're a screw, you're a transistor. And this is your rating, this many volts. So, and that tiny language model can process all that and understand it. And there's no generation and there's no room for hallucination because the objects are constrained by their actions, which are the algorithms, and those algorithms are deterministic. Programmers wrote those algorithms because the programmers understand the workflow. They understand the relationship between the stakeholders. They've done all that data flow analysis and control flow analysis. They embed that knowledge into the object deterministically, right? When they talk about AGI, it's going to be God is going to solve all the problems. Or really? So you got this magic AGI today. Let's say you bring it to Daniel's company. You turn it on. What does it do? And how does it know anybody? And what did you train it with? What data? I mean, it's like, say you just made it beautiful and perfect reasoning 100%. If it's 100%, then it has a lot of deterministic aspect to it. So why do I need to waste my computational power and put parameters in computing to try to draft deterministic results out of a probabilistic engine? You see when you analyze from a first principle, any of these approaches, you'll see the shortcomings and you'll see that they're not going to be able to deliver what they pretend. They don't directly define them. They pretend, they infer. That's how you create hype and you don't commit. You just make, go look up OpenAI's definition, AGI, tell me to make sense of it for me. And I invite anybody with a computer science degree to go and read it and define it for me because I don't get it. I don't know what to build for them. I don't know what they're working on. And it's not a secret. You got to tell me, does it run? Does it have, we know what FSD is. It's full self-driving. We define it. This is a degree. It's got to be able to pass the red lights, don't kill people. Measure this for me, right?
So, what I actually wanted to know from you, just wanted to digress a little bit to what you're building at Omadeus. So, what's like the core vision behind this, and like what specific problems in project management are you guys able to solve with AI here? So, are you also like incorporating small language models here anywhere? Just fine tuning only on project management with Omadeus. Like, how are you able to make the product better?
The project management algorithms are not coming from the AI machine. Understood. I mean, we just like traditional ways, we know that there's a project manager, there's a programmer. For example, if you go in for technical people, there's a designer, there's a back-end developer, there's a front-end developer, there's a QA. So all this stuff is well known, right? Nothing needs to be trained on an AI. What we do is we say, instead of creating dead, lifeless issues, just like Jira, you create an issue, that's just a record. You create a record, it goes into a database. That's all it does. You create in Omadeus, for example, which is just an application. I mean, that concept, we basically are talking about a platform, a whole technology platform that's applicable to every vertical. And that's our whole IP. We've already filed about 7 patents, and we got another 6 in the queue. And hopefully they'll start issuing next year. This is about 3 years now we've been in the process. But the intelligence is embedded in that record that I create. I create that record, and I create an issue request for a feature, for example. I need for that screen button that blinks 3 times and it needs to be red because I got a customer for it. They want to buy 10,000 or whatever, right? And the minute I create that object is intelligent. The intelligence is not in the frame, it's in the object itself. It has autonomy, it has self-awareness, it knows who it is, it knows who created it, it knows what I did, what I want from it, and it'll fly into Daniel's inbox and say, hey, I'm an issue request, because the object knows that Daniel is a project manager. And by the way, if you're the backup project manager, it'll also fly into your box and say, because it's fault tolerance. These are like basically best practices that we, as designers of project management systems, with expertise, deep expertise in the domain, because we're software developers, we've used all kinds of in the past. Daniel is probably doing this today. We cobbled up Jira, Trello, Slack, bunch of these tools to try to solve this problem. I mean, that's why we have domain expertise in this, and I know this is how everybody's doing it today. But all you need is just this tool, and it'll handle all of it. But it's all coded. It's coded in algorithm. The intelligence goes into the object. So when the object shows up in front of Daniel after 50 people have been banging on it and changing it and doing it, Daniel, as a CEO, looks at it. He doesn't have time to make a decision to read all this stuff. It just says, ask the object, give me your top highlights. Boom. Who's your client anyhow? Who made the best suggestions of your color? That. Whatever, he interrogates that object as if it's a real person. The beauty and the intelligence is in the object. The pipes that flow around, those are predeterministic. So we've determined ahead of time based on the workflow. Now, create fluidity in that workflow. There's a programmer to do that, right? Based on conditions, right? And the object can have the intelligence that when you get the juncture, you can go left, you can go right. Look inside you. If you're this, go left. If you're that, go right. Or start reading a report, right? Then this is what was not possible. Read that report. If it says this, go upstairs. If it says that, go downstairs. Just like a person. So you've put the intelligence. Now, that programming-wise, today can be simulated with an LLM. You simulate it. But in the future, they're all going to have incorporated TLMs in them, and they run on their own processors and their own memory space. And that's how you optimize computation in a parallel processing mode. So this model is so beautiful that it solves the computational energy problem. It's optimized. It solves the communication problem where it guarantees that the second you lower the priority of that object, you don't have to send it to me. The object comes and tattletales on you. Programmers are still involved, which is understanding of these environments, which is rich, needs to be encoded. But the way it gets encoded is different now. We don't deal with dumb forms. We create intelligent objects with these pipes that are skeletons that represent dynamic workflows. Objects are self-contained. They manage all the information about themselves, including the communication between individuals. Because when you come to work, when you and I work for Daniel, we're making radios. We're there not because we're there to talk about football. We may do that, or go play golf. But our conversations that are meaningful are about that transistor that's coming here late or on time, or the voltage is not right on. But that conversation, the pivot of that conversation needs to be the transistor, not you and me. And that's really embedded in workflow-based communication, which is really the root of our solution. And then AI is just the part that attaches itself and gives language understanding capabilities to that object, and then allowing it to interact with users in a very intelligent way about itself. You cannot ask a transistor, how do you make a pizza? But when you ask it a question and say, who created you? He's not going to hallucinate. He's going, well, Daniel created me on this date and then just structured it. No hallucination, right? Because the attributes of that object constrain it to this. It gets fenced automatically.
Any special insight that you've got that will really help founders or someone who's building workflows, would really appreciate that. Just one insight there would be super helpful.
That's a great question. I haven't thought about it, but I have probably a quick answer, and I got to think about it longer and maybe a better, wiser answer. My quick answer is there's a lot of hype about LLMs and AI agents and all that. And then, like I said, AI agents came into existence. LLMs were not all that useful. For them to do anything in real world, you need action, and action is done through algorithm, and you attach algorithms to these things, and they start becoming a bit more useful, but in very specific areas. I think in the next round, the real bandwagon is going to be what Daniel and I did. When we moved to the internet, people like him and I, we started saying, wait a minute, this electronic medical record stuff is old. These are all stuff. Let's move them to the internet, and not the old generation didn't want to do that. New generation wanted to do that. So we made two very successful companies out of that because there's a need for it. It's real. Okay. A lot of the tools and toys that I see today, these are just made up by engineers for engineers in a way. It's not demanded by the market. We have real problems with companies. Okay. And it's about information overload. It's about improper routing and information. We have a lot of traffic that gets created because information sits in silos. They don't move from the right person to the right person. The management and storage, where did so-and-so put that file? Where is that? Where is this? She left. We have no idea. This is what we're dealing with. Okay. These are real problems. Okay. Not generating fake video. Any young founder, entrepreneur who understands and begins to understand, if they start crafting AI native software, that's what this is, which is thought from the first principles, which is forget the existing algorithm, the one model, start with the data and make your data intelligent and give the algorithm to your data. Don't let the algorithms manipulate your data. Get the data to execute algorithms based on what happens to it, right? So it's just completely flipped on its head.
Fast forward 20 years or 10 years, you're working on this problem. Like, what do you see as like what's going to happen with Omadeus and just AI in general? Like, do you see it going towards like what the rabbits of the world are trying to do, or do you see it being like little helper objects that are AI based, or is there something even bigger that we're missing that you think is going to happen?
If you're going to build something that rabbit AI promises, the way to do it is with our architecture. Because once you actually redesign software that is composed of thousands or even hundreds of thousands of intelligent objects that understand language, and they're organized like hierarchically in a network fashion, and they understand each other, the way we did Omadeus, for example, we have a main brain in Omadeus, for example, that understands all these other objects. It's a hierarchy that says that, and the user now, I have to give you a demo of that. You can go to Omadeus and say, Omadeus, list all my outstanding late projects. Oh, okay, that one. Oh, show me why that's that's the three features that are late. Oh, show me who's responsible for that. Oh, this programmer and this designer, they're late about. So Amadeus knows everything about it, and you can interact with language using just pure language. Now, once you have a software like that, and two different software that are built like that, they can communicate with each other using language. We'll have a world where software will talk to software, okay, and exchange data based on, and they can all the issues with security, with privacy. This model solves it in a very beautiful and elegant way. And it does. And, it's funny as we started engineering this, because it's one thing to have a theory and a paper and another to build an engineering system, which is what we started doing 3.5 years ago to try to say what this is like. We were surprised to see how beautifully all these problems are solved ourselves. But then kind of realize, well, that's what paradigm shifts do. That they simplify the world in a very elegant way, in an amazingly elegant way, because they are real. They match the relationship of external reality without the imposition of our prefabbed models like a paper form, right? So that's no longer, right? We can actually model the real world in a real way, just the way the evolution intended to look at it. In a way, it's reshaped. Look at the way biology is made, the way humans interact with each other, right? Or the way your body manages your kidney, your cell, all that, right? And it abstracts it. You don't know anything about your liver or your stomach until it starts hurting you. Okay, but you know immediately, right? Or your hand, when you put it on a fire, you immediately find out and you pull it back. When we build software like that, companies, management becomes so in tuned with the pulse of the company that creates unparalleled transparency. To go these stages is going to take. It took about 20 years to go from desktop to the internet. I think this is going to take about maybe 5 to 7 years. And a lot of it is going to be automated. And we want to be a big part of that, not just selling project management in this model, which is really the start, but it's the technology we want to promote. And like I said, 80% of all applications, because of the messaging framework, we already have that. So we could really share that with a lot of different verticals.
Awesome. Well, thank you so much for the explanation on that. It's going to be an exciting future, but I kind of see the vision of like where you're taking it, and it's you're saying it's like an organism where all the parts create the sum, and then they all kind of work together in tandem, and they're all in sync. AI is going to enable a lot of that for us in the future. So that's a really bright future, actually. A really good future.
Right. I think so too. I think the future belongs to the engineers, because we're going to craft a lot of this stuff. You're not going to be able to spit these things out of AGI. I'm sorry. You need engineers to analyze workflows, control flow diagrams, and data flow diagrams, and then map it to this new model. And it's engineers. We can use a lot of AI to automate a lot of our nitty-gritty stuff. Great. Like I said, the 80% of it is just messaging, and that you can start. So it's going to be a lot faster.
Masood, it's been an amazing conversation here. Just got to learn a lot from here. I'm definitely going to rewatch the podcast again, because there's so much data points that I got, and I can just dive deeper into each point that you said, and it's like an ocean of knowledge that I can uncover. So Masood, it's definitely been great to have you on the podcast.
Yeah, thank you so much for being on the podcast. This was a great episode. Super insightful, honestly. It gets me, whenever we talk, I always get invigorated, and I'm like, you're seeing it far out. So I love your broad perspective on everything. But I mean, with that, thank you so much, Masood, for being on. And
thank you, Daniel. Thank you, Harshit, for having me.